vision-wise, what we're seeing is that information, communication networks, computation are hitting limits in different senses, right? Limits of we cannot protect information enough, or we cannot digest. We're generating so much information that we cannot digest it. And what we strongly believe is that quantum technologies will help us overcome these limits, and enabling technologies like photonics and quantum components, as Quside is building, that will help our partners and our customers and our ecosystem overcome the limits in connectivity and computation.
Hello again, welcome to another edition of Photonics One-on-One, where we have the chance to talk with some of the present and future leaders of the photonic industry. Today let's go to Barcelona in Catalonia, Spain to meet Carlos Abellan. He is the CEO of a company called Quside, which combines everything I love of photonics with a clear vision towards enabling the transition to future-proven encryption solutions. Quside is a fabless company with the goal of using integrated photonics and quantum technologies for the generation of pure random numbers. They are one of the first companies worldwide to launch a quantum product for the non-academic use. So let's find out how it all got started.
So I'm actually a telecommunication engineer, so I started telecommunication engineering. So at that point, at the beginning, I actually started because I love audio, right? And I wanted to do that. But at some point in the middle of my degree, I loved cryptography. So I started to be very much interested about that topic. And then I took some courses on quantum physics.
In which university did you study telecom engineering?
Polytechnic University of Catalonia.
Okay.
UPC, yeah. And then eventually when I was going to do my undergraduate thesis, I said, I need to do something about crypto and quantum physics. And I discovered there was something called quantum cryptography, right?
Oh, wow.
So then I started looking for places around in which I could work on that. And I found ICFO. And I joined ICFO team, Antonio Thin, Valerio, and Morgan in a joint project. And I started working on research with them, with that in mind, working on something
Which year was that? When did you join
2012.
ICFO? So directly from the university.
Right.
So the idea of having telecom engineering and continue studying towards quantum physics, which is, by the way, exactly what I did. But I did it because I finished my telecom engineering degree in 2001. And then you wanted a job in telecoms, you either sell Movistar phones or you study something else. So I studied quantum physics and then I did a PhD because of quantum physics, basically the same thing as you. But why did you move from telecom engineering to something like quantum? Was it just because you like quantum cryptography? What was quantum cryptography for you 5 years ago? It was just the beginning of everything.
It was really the beginning, yeah. So basically, it was cryptography that I liked, right? Okay. And the thing about, so it was already a boom, right? But it's not as it is today. And all of these challenges about protecting data and privacy and stuff was something that was interesting to me. And there were tools to tackle that issue, right? And then it was more the curiosity about quantum physics and just the curiosity to explore what was that about that led me into finding about quantum cryptography. So it was about doing something I liked, cryptography and protecting data, and exploring something new that sounded exciting, which was quantum. And being there at the time, probably, that thing started to emerge.
Telecom engineering prepares you for cryptography in a, correct me if I'm wrong, in a software kind of level, right? You are talking about generating a key, encrypting a message with a key, having the key, using it for decrypting the message, and securely communicating the key. But it's all a software level. When at what point in ICFO you realized that there was a hardware level solution that you could actually investigate?
So exactly. So everything that we studied in telecom was related to security, was about protocols and encryption algorithms and stuff, right? But at the same time, we had all the lessons on hardware. So we more or less knew how to build electronics and these sort of things. We also saw optics and stuff. But it was really at ICFO and understanding quantum crypto that you start seeing that something that is fundamental to crypto, right? Which is you make assumptions. You make assumptions to prove some sort of security, which are computational assumptions, and that's right. But you realize or you learn that there might be other sort of assumptions that you can make, which goes into the physical world. And then now you know the two options, and then you can choose or you can continue to elaborate and build hybrid systems, whatever. But that was probably the change about thinking just about the security and the algorithmic or that piece and moving into the hardware and the physics of it. And something exciting was this, changing the paradigms on top of which security is built upon. We had the opportunity to test this in a real environment with a partner, right? So we really built a prototype that someone else could use. And I loved doing that with my engineering bias, right? So that was a very exciting time. And when I finished the thesis, we not only did the demonstration of the fastest QRNG at that time, which was more a research milestone, we also built a prototype that people could use, right? We didn't publish that. That was not something publishable or that you would do with just a pure science career path in mind. So we were spending a massive amount of time on that just for the sake of demonstrating it could be used and it had value. So then we jumped into the PhD and we started having this dichotomy of development. One very fundamental work on bell tests. We did work together on bell test experiments and something we called randomness metrology, which is very, let's say, fundamental or scientific. And doing a lot of technology innovation with photonic integrated chips, with building prototypes, electronic cards, and demonstrating the application. So that was the path, and the transition was the natural step of continuing working on something that, that there was excitement about at that time that I loved. And
there are two aspects here. This is when the magic is starting to happen. So first, I can see that you mentioned for the first time photonic integrated circuits. That, of course, was really the beginning of Quside, when you came up with bringing these two worlds together, the quantum and the integrated photonics worlds. And on the other, I start to feel that you, at some point in transition between the master and the PhD, you had already a product in mind, an industrial product, something to bring to the market. So I'm going to ask you first the second question. When did you realize that was an industrial level innovation that could actually make us a technology business?
That's a good question. So I would say that, and this might be something quite common in our sort of development, right? Something that starts from research and eventually you find a spot in the market, right? This is the approach I would say in our case. Then there is the typical entrepreneurial path, which is the other way around. You start with the gap and then you find how to solve that, right? So it was obvious that the application on cryptography was there. So there was even a company in the market that was doing not just one, couple of them. And so it was a basic element of cryptography, and technology-wise, it was a better solution. Now, the question was not whether there was a market or let's say that we are opening a new market, but whether we can build the technology and that the benefits of quantum and the high speed that we could bring could have a value on the market or would be able to replace the way that people was doing that in the past. So let's say the assumptions were narrowing at the beginning were larger, and then we started learning that some applications really needed high speed, like high performance computation or quantum distribution, or problems that people have in practice, right? That they did not have enough quality in systems already deployed. So that was a journey of discovery, if you want.
So we are now in the moment in which you have an idea to bring innovation to the market, and you mentioned that photonic integrated circuits is a technology that can actually be suitable to what you want to integrate. How was your first touch with the photonic integrated circuit community? And I would like to highlight that at that time, ICFO or ICFO was not a main player, was a key player in quantum technologies, top of the top. But in integrated photonics, there were not many projects at that time. You were one of the first ones that actually brought the photonic integrated circuits to ICFO, to ICFO. How was that experience? How was the relation between you and the photonic integrated circuit community wanting to bring their technology to your product?
I think it's about people and relationships, right? So I think the point was, on the one hand, we were already collaborating with people in Valencia and VLC Photonics. Our first paper, we worked together, right? So that was the first connection because they are very strong on photonic integration, right? And of course, the personal relationships of Waldemar and also Valerio with David Domenech and other people at VLC Photonics was the first step or the first connection, right? And then it was Valerio that had the vision of saying, hey, let us use this photonic integration for implementing what we have to do, because he also had experience in photonic integration in the past with lithium niobate modulators and these sort of things. So we just got on the wave. And the interesting thing is that I think we were one of the first of using a multi-project wafer run that was somehow offered to the outside. Maybe not the first, but really it was the beginning, right? Years before, it was either within a research collaboration or a research project, but was not that commercial. So that was, I would say, game-changing in the sense that someone with, let's say, not millions of dollars to build a foundry can just test and prototype an idea, right? And now that's more consolidated, and there are great places in Europe to do that. But at that point, I would say we were one of the first to be a user, just a user of the technology.
But you were developing a product, and you had the idea of putting a product in the market, and you already mentioned that you knew there were competitors. You knew there were companies who were developing such a product. Were you worried, concerned about the cost effectiveness of the technology, taking into account that you were jumping in a low level of maturity?
So at that point, actually, there was no chip in the market for QRNG. So everything that was available was large, expensive, and slow. So it was really not there. And our first milestone was more than a product, just demonstrating that it could be put in there. So it was the first fast photonic integrated quantum entropy source that we managed to put on an indium phosphide chip, monolithically integrated, right? Everything was on the chip. Then, of course, things evolved. That was 2014, more or less. Yeah. Now there are some other cheap approaches. But at that time, it was even a technology milestone that could enable QRNGs to scale. Because up until that time, it was not possible. It was big boxes or big devices.
Your PhD was going really well. You got fantastic results, fantastic publications. I saw many of them in your LinkedIn page. Fantastic articles, by the way, there. You finished your PhD December 2017, and Dr. Abellan wants to start a company. Tell me about these beautiful times.
Something that is great that ICFO is this technology transfer unit that already from the early on incubates together with the researchers the technology so that to bring a path to market. What happened really was when we demonstrated the chip and we managed to publish the results. At that point, it was, okay, we agree that the science is over, right? So everything about the science of demonstrating that this can be put on a chip and still maintain the quantum properties, we've achieved this, right? And we know that if we can scale the technology and make it, of course, if this technology costs 10,000 euros, it will never have a chance, right? So really, it's now about investing in the technology so that we can scale it to the volumes and the cost that breaks the market barriers, right? So it's something that is fundamental. If it costs $10,000, you're not putting it in many of the use cases. But if it costs a few dollars, then it can enable many markets, right? Mm-hmm. Everything was continuing. So we were making good progress and at good pace, and the team was there. So we decided to spin off the company. So
at this time, you were talking about 2017, is the boom of quantum technologies, right? There's startups going everywhere. I remember there was a presentation from who was it? I think it's OIDA in the US. They had a presentation which they map all the different startups, and there were startups appearing especially in California area, but everywhere in Europe as well. The creation of the quantum flagship. It was the time to talk quantum. Did you think that was beneficial to you, or do you think that there were some people maybe over-promising that made the quantum, for some people, not being a real technology?
So let's say all of the heavy lift, we did it at the end of 2016, beginning of 2017, right? So then it was about just closing that effort. So all of this wave, I would say, came after we decided to spin off. And it was something very positive for us, right? So basically, then the quantum flagship started, and we are one of the few fully quantum startups that are part of the flagship. We had the chance because we already existed at that point, right? So we had to do it before, and then we could participate in this program. What maybe some people might think companies are overpromising, especially on the quantum computing realm and when these things might happen, right? So, but we're not doing quantum computing, so I cannot make a statement. But I would say it's not about overpromising on what the technology will be able to do, but when that's going to be able to happen.
So we are not transitioning to the second part of the interview. It is obvious you did not overpromise because you are one of the first startups in Europe that has put a quantum product in the market for not only academic use. And that's remarkable. Tell me about what happened between 2017 when the company started until last week when you released the product.
There are two big milestones that we set ourselves in 2017, right? One was proving even to ourselves that the photonic chips or the technology of photonic integration could scale, right? And there's a difference between making a chip and demonstrating it in a lab and building a repeatable process that can produce your technology at the quality that you need. So that was the first. The second one was about building the product. So something that we could put in customers' hands to start solving problems that they have and deployments and learning. And this was the second milestone, putting this product in customer hands, learning from these clients about their needs and helping us transition into the next generation.
In 2019, it was also a big milestone. You don't highlight because you are very shy, but something happened to you, right?
It's an interesting one. So actually I got nominated and I don't know by who. So
let me just say, since you are not saying it, so you were nominated as one of the highest level innovators in Europe, younger than 35 years old by the MIT.
Exactly. This served to, so we were already working for a while at Quside, right? And we were very inside focused at that point for hitting these milestones that I was talking about. So we needed to prove first that we could make it into a given scale before starting there. We were very internally driven, and that was the first time we were outside to the outside world, right? That was great for the team to see that there was recognition for the work that we've been doing, for what we're doing, and that opened doors, right? So we started talking to different people, and it's always some sort of external validation to the technology and the innovation that we're bringing to the market. So
today is the day in which Quside is a very well recognized company for making a quantum random number generator on chip. How many people work now at Quside?
So at the moment we are above 20 people.
20 people.
Above, so 22, 23 people at this point in time.
23 people. That's 23 families who really need to make sure that they bring the money home. It is a responsibility, I know, because Epic, when I joined, was one person, and now we are 15, and I'm worried. Imagine 23 is even higher level. When did you realize that you wanted to build a team, that you wanted to build a team around you to help you with that dream that you had during your PhD?
I think there's no way you can do these things alone, right? There are so many infinite amount of things that you need to get done that you need people. You need people that are better than you on everything, right? So we are all told that building a team is something hard that takes a lot of time, but I don't think that until you're doing it, you realize about the complexities and the effort that you need to put into making these things work, right?
In the beginning of the presentation or the interview, you started talking about colleagues at ICFO. During the meeting, you talk about the team. When I told you about your award, you said the team, and now you mentioned how difficult was to assemble a team of 23 experts.
So people like us, that we come out from a research institution like ICFO, that there's such a massive density of talent, we can leverage that, right? So we have either people on our team that we are the ones that start, and people on related teams that have known about what you've been doing for years, listening to your talk. So it was easy to attract the first batch of people out from ICFO and then get them on the team, right? Then, and you already have a relationship. Then you need to bring people from the outside. In our case, was more on the engineering side, right? So the science was great, but you need to build products and PCBs, right? So you need to start hiring people that is not as easy as it is to get a recommendation from your trusted network. To me, that's about adapting and recognizing that team is essential. Without a functional team, the technology is not going to be functional. Then I think that's the core of the way I see this.
You had the most important milestone, in my honest opinion, the most important milestone of the rest of Quside happened last week with the product launch. But now I want you to dream about your preferable future, about your ideal future. We had this conversation, which we will in about 5 years. And what is it going to be different? How is going to Quside look like?
So I think that the simplest way to explain what I see is that every bit that's going to be sent online by 2025, whatever the date you name it, is going to have interacted with a random number generated by a Quside chip. So that we're going to be enabling a new wave of safe connectivity in many different areas, and the technology is going to be enabling in that respect. So we see Quside as the first step of Quside as enabling the safer connectivity. And then dreaming beyond this, and this is something important for us, we've been building interesting capabilities, right? So from photonic integration, RF, our optoelectronics, high-speed optoelectronics and stuff. So we can do many interesting things in this realm.
That's a dream.
That's a dream.
That's a dream. But that's a huge, I mean, if you want to put it in every communication link, we are talking about a huge volume production. To reach that preferable future, you said it before, you said it very well, nobody can do anything alone anymore. So what could be the ideal, the dream partners that you need to be with you in this adventure?
So I would say in our value chain, we are in a spot which is very simple. So we are fabless, so we need our manufacturing partners, and we need our system integrators that take our technology and bring it up, right? So these are our direct partners, the ones that manufacture for us and the ones that we sell directly to. But something that is essential for us is to work across the full value chain, also with the people that will eventually use this technology. And I can put an example, like, for instance, a bank or whoever, they want security for their customers, and they're going to be procuring equipment from server makers or networking equipment vendors.
Is it difficult to talk to the end users? You're talking now banks or online gambling, or you go to the really end user side. Is it difficult to make them not only interested, but to make them help you with a roadmap to solve their future problems?
So I think it's 10 million times simpler in 2020 than it was in 2014, right? And I think there are different elements that make this happen. One is that quantum technologies are on the press now, so people know this is something they should look at. Let's see then if it's interesting or not, but they should look at. The second one is about security. And security is changing. This is something that people that should worry about it know it. And they need to be flexible towards adopting where this is going to be. So they need to be proactive into adopting something that they don't know exactly what it's going to be. And this concept of agility, or crypto agility, some people call it, is essential, right? And the technology that Quside provides it's the most agile solution for random number generation that they can choose, because it's fast, because it's quantum. I think the message is building a company is hard. It takes a lot of effort. You need perseverance and you need passion, right? Without these ingredients, it's going to be hard to make it through the ups and downs that come with it. So building a company is hard, building a team is hard, but the reward is incredible.
Fantástico, lo dejamos aquí porque ha sido increíble.